Hello everybody. So today we'll be learning Hemming code. Okay. So let us see who has developed the Hemming code. So Hemming code is developed by R.W. Hemming. So this code is used to find a single bit error. Okay. So that only I mentioned over here. It is used to identify a single bit error. This code can be applied to any length of data units. Okay. So the length may be whatsoever. Okay. But the error which you can find is only a single bit, right? So here the data bits which we are taking in Hemming code are represented as M. Okay, so we'll see how to represent that also. The redundancy bits are represented as R. Okay, these redundancy bits are responsible to check whether there is an error or not in a particular group of bits. We'll see those things in a detailed example, right? The number of redundancy bits in a data is calculated by 2 to the power r greater than equals to m plus r plus 1. So this is the formula which will give us how many r bits or redundancy bits we need for a particular group of m bits, right? Now the next point says that if at all we have certain m bits, okay, what will be the r bits we should take, and thereafter what is the position of the r bits. I mean to say that where we put the r bits. So that clarification is given in the next point. So here we have mentioned that the position of redundancy bits are calculated as follows. Suppose 3 r bits and 4 m bits are there. Okay, I have taken suppose. Okay, I will solve an example and show you. Before that, let's assume that I have 3 r bits, okay, and 4 m bits. So 4 plus 3 is 7. So m plus r is 7 bits. So altogether the data bits will be of 7, right? So if I have total 7 bits to be transmitted, okay, then r bits are represented as r1, r2, r4, okay, in powers of 2. Okay, for example, the next r bit will be r8, 1, 2, 4, 8, 16, 32. In this way it will go on increasing. But here I need 3 r bits, so I have taken r1, r2, r4. Okay, this example is just to show you the groups of r. Okay, so whether it is 3 bits, 4 bits, it depends purely on the questions given to you, right? So here I have taken r1, r2, r4, and then I have taken another position as 1, 3, 5, 7, 2, 3, 6, 7, 4, 5, 6, 7. So how I am getting this position? Just have a look. Because I got m plus r is equals to 7 bits, okay, so 7 positions I have taken. For example, if it is 9 position or 10, m plus r equal to 10 or 11, so 11 positions I will take. So in this case, I have taken 7 positions, right? Now I am going to represent the 7 position in binary format, and for that I am taking the r values r1, r2 and r4. Starting from 0, 0, 1 till 7, I have represented in binary. Now if you see vertically under r1, wherever you find 1, those are the group fellows of R. See at 1, 3, 5 and 7. So I have taken the group 1, 3, 5, 7 over here. You can see this little point. Okay. Similarly, I have taken R2, and over here vertically I have checked the number of 1. Okay. Accordingly, I have taken the digits for that. So there is 2, 3, 6, 7. Similarly, 4, 5, 6, 7 for R4. For example, if it is 11 bit, I should have gone for R1, R2, R4, R8. I represent that in form of binary, and then I have taken the group from that, right? Okay, let's move to the example then. So here I am considering a message, okay, that is 1001101. This is the message I need to transmit. Okay, so what to do? If I need to transmit this message, I need to introduce r bits into this one. Then only it become m plus r, and the message will be ready for transmission, and that will be coded message. Okay, so how to introduce r? Okay, that I have explained over here. So let's go into that. So here m equal to 7. If you count this one, we have 7 bits. So m is equal to 7. So this represent m is the data bit, right? Then how many r bits I need? So I will implement the formula to the power r greater than equals to m plus r plus 1. This formula I will use. Okay, this formula I will use, right? Now using heat and trial for r. Heat and trial means first I will take r equal to 1, r equals to 2. In this way I will go on proceeding, okay, and then finally I found that when r equals to 4, this is satisfying. 16 is greater than equals to 12. So I got satisfied over here, or the equation is satisfying each other over here, the conditions, right? So I need 4 r's. So in power of 2, so I have taken r1, r2, r4 and r8. Okay, just now I have shown the table. Accordingly, I will take positions. How many positions I will take? That is, for this bits 11 positions. Okay, why? Because when r equals m equal to 7 and r equals to 4, so what will be the m plus r? If I check for m plus r, m plus r will be 11, right? 11 bits. So that's why I have to go for r8, r4, r2 and r1. Okay, and the positions will start from 1 to 11. So when I take from 1 to 11, under r category, wherever I will found 1, that I will take as a group of the r's. Okay, so for r1 I am getting 1, 3, 5, 7, 9, 11. r2 I am getting 2, 3, 6, 7, 10, 11, and r4 I am getting 4, 5, 6, 7, r8, 8, 9, 10, 11. So these are the group for which each individual r are responsible. Okay, now I am forming the table, and from this table I will get the coded message to be transmitted. So for that, what I have done, I have taken positions. So total m plus r equals to 11. So I have taken 11 positions. See, from 1 to 11 I have taken. Okay, what is the data? The data is this. So first of all, what I have done is that this r1, r2, r4 and r8 I have introduced in the place of this position bit. See, under 1 r1, here r2, here r4, here r8. So the place of r is fixed. Thereafter I have placed this data starting from here. That is, if I count, I am getting 1, 2, 3, 4, 5, 6, 7. So starting from here, this 11th position, I have adjusted the data, or I placed the data over here. Okay, so altogether if you count, it's 11 bits. Okay, simply you fill up the r position, and thereafter you place the data in a sequential form. 1, 0, 0, 1, 0, 0, 8 position left, then double 1 is there, double 1, then 0, then the last open value is 3, so here I placed the 1. So I got my r plus m combination over here. Now since in this question nothing has been mentioned, so by default we will take even parity to be used over here. Okay, if the question is specified go for odd parity, you have to go for odd parity, otherwise we have to go for even parity. So just pay attention and have a look over here, how I am placing the values over here. You see, for r1 I have to go for 1, 3, 5, 7, 9, 11. So first of all I am leaving the one position, I am leaving that one, lastly I will take that one because this is r bits. So next is 3. So 3, what is the value? It's 1. I will copy 1 over here. Then 5, 7. So 5 value is 0, 7 value is 1, 9 value is 0, and then I have 11. So if you see, the number of ones over here are 3 in number. So that means it is odd. So since I am following even parity, I will have to introduce one single 1 over here to make it 4, 1. So one position I kept it vacant. So in R1 I will place 1 over here. So this become even number of ones. In the similar way, I am going to fill up R2, R4 and R8. So let's see, for R2 it's 2, 3, 6, 7, 10, 11. Okay. So for 2 nothing is there. I will keep this vacant. 3, 3, 1 I am copying. Then 6, 6, 1 I am copying. 7, 1 I am copying. And then 10, 0 is there in 10, you can see that I copied, and then 11 I copied 1. So you can see 1, 2, 3, 4. 4 ones are already there. So what I will put for R2, I will put this one as 0. So these are even number of ones. Similarly for R4, it's 4, 5, 6, 7. So 4 nothing I will put right now. 5 it is 0, 6 this is 1, and 7 this is 1. So it is already even, so R4 I am taking as 0. Then 8, 9, 10, 11 for R8. 8 is how much? Okay, keep it blank. 9 is 0, 10 is 0, 11 is 1. So single 1 I will put R8 as 1. Now you see vertically, okay, the digits or the bits will be same. So I'll just copy the bits. You see it is 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. So this is the coded message. This is the message to be transmitted. This is the message. This is the message. Okay, that is coded one. Coded means it is having R bits as well as M bits. Message coded to be transmitted. To be transmitted. I hope you understand what is happening at the transmitter end. Now assume that this is the message I am to transmit, but while transmission there is an error. Okay, so the machine is capable of rectifying the error or not, to locate and rectify the error or not. that I'm going to check. So what I'm going to do is that in this 11-bit message, the 8-bit, you can go for any bit, I'm choosing the 8-bit. That means I will start from my right towards my left. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the 1. I will convert this 1 into 0. So in place of this message, I'll be sending the message, an error message, that is 1, 0, 0. In place of 1 it will be 0, 1, 1, 0, 0, 1, 0, 1. This is the error message, where the error is over here. So this message I am going to transmit, and I will check whether the machine is capable of identifying this error or not. Okay, so let's see that. So I have taken the message. This message is 1 0 0 0 1 1 0 0 1 0 1. So this message I received. So at the receiver end, what I will do, again I will take the position. So 11-bit I have taken the position, message received, this message is copied over here. Okay, and even parity check I will do over here in the receiver end. So R1, R2, R4, R8 I have taken. This side for correction or for checking I have taken C1, C2, C4 and C8, and just this I have written just for my reference. Okay, because I have to know which are the groups for R1, R2 and R4 and R8, right? So I will just, as per this group, I will just copy the values over here. That is 1, 3, 5, 7, 9, 11. That is 1, 3, 5, 7, 9 and 11. I copied this. Then 2, 3, 6, 7, 10, 11. So that is 2, 3, 6, 7, 10, 11. So 10 and 11. And thereafter R4, that is 4, 5, 6, 7. So 4, 5, 6 and 7, and finally I have R8, the 8, 9, 10, 11. So that is my 8, 9, 10 and 11. Now let us check the even number of ones over here. 1, 2, 3, 4. Okay, so R1 is okay. For that group, he has done his best work. So there is no error over here. Coming to R2 is 1, 2, 3 and 4. So this is also even. So there is no error over here. R4, okay, that is 2. So there is no error over here. Coming to R8, error over here. There is an error over here. Okay. Now, if I erase this particular bits, okay, that is correction bits C8, C4, C2 and C1, and I put the values 1, 0, 0, 0, it is showing me that the 8, because this is the decimal for binary for 8. Okay, so if I convert that, I am finding 8. So this is the 8th bit where the error is. So if I check this message right now over here, that is 1 0 0 0 1 1 0 0 1 0 1. The 8th bit is this one, and here the error is. So how to rectify the error? Just to complement that one. So if I complement this, I am getting what? 1 0 0 1 1 1 0 0 1 0 1. So this is the correct message. Okay. So this is how we are identifying and rectifying the error using Hamming code. Thank you.